Hi, everybody. Welcome back. So this should be the last part of the function lessons, and it's all about function scoping. So the word scoping, I want you to think about this as like a telescope, okay? So when you move a telescope around, you're able to see things in your field of vision, but you're not able to see things outside of your field of vision. So if I'm using a telescope, then I can only see the stuff that's happening right over here. There may be something over here, but I can't see it because I haven't turned my telescope to see it. Okay. Functions have a telescopic vision, if you will, of what they're allowed to see and what they're not allowed to see. Okay. And we're gonna talk about that and sort of how this works and why it's important. Okay. So if I create an object called out, so I'm going to go back up here and we're going to talk about our absolute value function here for a second. I created an object called out inside of the function called absolute value. Now, if I put another object called out into my global environment, and this is a character string, this is clearly not a number, okay? Which means that if I like they what's going to happen here if I try to perform this calculation. So let's go ahead and do this. So we're going to say absolute value is a function of a number x, and the operation is store. And actually, we said that it was numeric. We specifically wanted it to be numeric. And so we say that whatever the out is gets assigned to be the numeric. And then we say if the numeric value, so numeric is less than, or I'm sorry, greater than or equal to 0, we're going to do nothing. So greater than or equal to 0, then we are going to do absolutely nothing. We're just going to give the value back. So return, and notice this changed color. So it's the same color as function, if, return. These are all reserved words. So then we're going to return out the original number. Otherwise, we're going to multiply. So -1 times out. Okay. And so let's test it. So we're gonna run this thing and we're going to test it. So absolute value of, we said -5 should be 5. And if I copy this thing and just test the value of 5, I should also get 5. Okay, now so over my global environment, I've got the absolute value, and I'm going to create something new. I'm going to create an object called out, and I'm going to say this is not numeric. Okay, now I need to multiply -1 times out if I was calculating the absolute value of a negative number. Okay, so let's create the object out. So you see out is over here, and it is not numeric, it is character string. If I do this, -1 times out, it's going to give me an error, and it's going to say it's a non-numeric argument to a binary operator. So I'm multiplying a number times a character string. This is not going to work. Well, what's going to happen to the absolute value function? So I'm going to put in -5, and it's going to do -5. It's going to do -1 times out. Is it going to work? Let's find out. Yes, it works. Why? The answer is scoping. Okay. Whenever I'm running the absolute value function, the telescope is not looking at the global environment yet. Okay. It's going to look only at the arguments of the function and the other things that I've built inside of this curly braces. Okay, this is very important. All right. And then if it cannot find something here, then it will change the telescope over here to look at the global environment. But before, it's going to try to do everything it can looking this way inside the function. So it's not going to see this value called out because there's already an out here inside the function. This is scoping. All right. Relatively complex idea, but I want us to wrap our heads around this. Okay. So this is an exercise for you, and I technically have done the exercise for you because it's very, very important. But still, pause and discuss what we just talked about. Okay, this is a critically important idea. So spend a minute or two, talk about it, write a question about it, and then bring it up in class later. Okay, so I'm going to pause. Okay, so hopefully you've had some time to think about a question of why this is happening, what exactly this sort of scoping thing is, what's going on with the scoping thing, and then we'll get into a little bit more of how this works. All right, so if you remember this diagram, we've talked about atomic vectors, we've talked about non-atomic vectors, and that was all into the vectors header. Then over the course of like this lesson and so forth, we've talked about functions, and then we've talked about language objects and how languages connect functions and vectors, but everything's an object. And then over here, you may have noticed this word over here, but we have not talked about it really at all. It has been environment, okay? The global environment is an environment, okay? However, notice, I want you to think about this as well. This, whenever we create the absolute value function, oh, I scrolled too far. There it is. Everything inside of here, in between this open parenthesis, this open curly brace and this closed curly brace, whenever I call the absolute value function, it also creates an environment, okay? So environments are very, very powerful. Environments are, and I gave this example that our global environment up here is kind of like the sandbox that we're playing in. Whenever we use functions, it allows us to create an entirely new sandbox that is completely separate and completely different from the original global environment. And we can perform calculations, we can mess up this sandbox, we can do all sorts of crazy stuff. And then at the end, once we're done in our sandbox, we take the last thing that we did out of that sandbox and we can move it back to the global environment. And what that allows us to do is it allows us to keep our global environment relatively clean. So unlike the for loops and the while loops where we did all of our computing and all of our calculations directly in the global environment itself, a function allows us to create a new environment that's sanitary, that's separate from the global environment, and perform all of our calculations in this new environment and only return the things that we want back to the global environment, okay? So a lot of really, really heavy lifting ideas are in this section right here. Environments bind object names to their values. Okay, so if you remember on like basically the first day of class, we talked about the assignment operator. Actually, it was I think the second day of class. The first day of class, we just did hello world. The assignment operator where we said, okay, I've got a container. I'm going to put the number 2 inside that container, and I'm going to slap the label X. So I'm going to put some tape on the outside and write the letter X on the outside. So this container is labeled as X. That's the name of this container, and it contains the number 2. Okay. This action of creating an object happens within an environment, okay? So that means that I could have one refrigerator, one lunch fridge with my name on it that says, okay, Dr. Gabriel's lasagna, then the date, and then inside there's some lasagna. But in another fridge, I could have an object of the exact same label with something else inside of it. It could even say Dr. Gabriel lasagna and then the same date, but inside of it, I've got like Brunswick stew or potato soup or something like that inside of there. Because those two environments are different, I can have two objects of the exact same name, but they have the same name, but they have different contents, okay? So the assignment operator binds the value 2, so right here, X gets 2, binds the value 2 to X inside whatever environment we're currently using. So if I type it right here, if I say X gets 2 right here, it's going to bind it in the global environment. But right here, notice if I inside the absolute value environment, the object out gets whatever the number is, Even though here in the global environment, I have a different object out, the exact same name, but it has different contents, okay? So the assignment operator works, whoops. The assignment operator is environment context specific. So whatever environment you're currently working in, if I'm working in this sandbox over here, the assignment operator will create objects in this sandbox. If I'm working in the global environment, the assignment operator will create objects in this global environment, okay? So to get to sort of wrap our heads around this, or to get through a little bit more of an example, we want to talk about this. The number, the out object is being created as num. The only way the function has access to num is if you give a value to num in the function, or if it can't find the value num in this environment here, it's going to look from this environment here over to the global environment over here. All right, so R is going to create an object called out in this new function environment, and it's going to store the number 5 because we said we give num equal 5 in this environment. Then R is going to check to see if the original number is positive, and if that's true, then it will return out. If it's not true, then R is going to reach this last line of the function. It's going to see this expression out, and it's going to evaluate it in the function environment. It is not going to try to multiply -1 times this is not numeric. We saw already that that would have returned an error, but our function did not return an error because it's going to evaluate -1 times out inside the sandbox over here for the absolute value function, not the sandbox known as the global environment, okay? Now, one thing that we need to think about, though, is if R cannot find the object over here in the globe in the sandbox in this sandbox, the function environment, it will look over here into the global environment. Okay. Then, if it can't find it in the global environment, you see this arrow right here? It's going to look through package environments. So technically speaking, when you use library to load a package, you add new environments for R to look through to find objects. Like the dplyr function was not in the global environment. The dplyr function, or like the dplyr functions like filter and mutate and arrange and all of that, they were not in the global environments. How did R know what they did? Well, R looked in the global environment, couldn't find them, but then said, hey, there's an environment up there that I haven't checked. That's the dplyr environment. I'm going to look inside the dplyr environment and see if I can find a definition for the filter function or the arrange function and so forth. And it says, I found it up there. So the scope, the telescope changes, R is going to change where the telescope is pointing at based on what it needs to find. If it can't find it in the environment you're looking in, it's going to look in the global environment. If it can't find it in the global environment, it's going to look in some function environment. And eventually it will get all the way down to base R code. And if it still can't find it, it'll say, oh, object such and such not found. Okay? Alrighty then. So here are some examples right here. I want you to run this code for yourself. Like, read through this, make sure you understand it, and then work on these exercises, particularly exercise 2. I'm sorry, exercise 2, highlighted the wrong thing. Think through what we just talked about with environments and how environments and packages are related to each other. All right, and we'll wrap this up for now. What we're going to do next time is we're going to build on our understanding of functions, and we're going to start using functions to do some pretty cool stuff. And so that is this chapter right here, functional iteration with purrr. Okay, so we're going to basically, instead of trying to use for loops to do a whole bunch of analysis, we can use purrr and functions that we write to do really, really cool things. Okay, so I will see you next time.